This is video 3 for Unit 6, Lesson 1 in Chemistry 2. So now we have all the pieces for writing net ionic equations. So the first thing that we're going to do is balance the molecular equation. Then we're going to follow these steps. We're going to use the decision tree and solubility table to decide what is going to ionize in water. We're going to balance the total ionic equation and write it out. Cross out spectator ions, and they must be in the same state and charge, and then simplify the coefficients if needed. If everything crosses out, no reaction has taken place. So with same state, what we're referring to is a state of matter. So remember that S is a solid or a precipitate. A little L stands for a liquid, a little G for a gas, and an AQ is aqueous, or dissolves in water, or breaks into ions. So we're going to take our first example problem. Here we have AgNO3, CaCl2, AgCl, and CaNO3 So pause the video, use the decision tree and solubility tables to predict the state of each one of these, so solid, liquid, gas, or aqueous. So go ahead and pause now and then come back. Welcome back. So on this, you should have an AQ for silver nitrate, an AQ for calcium chloride, a precipitate or an S for silver chloride, and an AQ for calcium nitrate. So what we're going to do, once we have those, we have to remember, did we balance this? And we have to put a 2 there and a 2 there in order to balance this. Now we're going to break up each one of these into ions to give us our total ionic equation. Remember that a coefficient is going to have to be multiplied by any subscripts that we have. So AgNO3 breaks up because it's an AQ. There's a 2 in front of it, so we're going to have 2 of each ion that's going to be in here. So we're going to have 2 Ag plus AQ plus 2 NO3 minus AQ. CaCl2 breaks up. We don't have a coefficient in front of it, so we end up with Ca plus 2AQ plus 2Cl minus AQ. So everything over here is just floating around as ions. But when a silver ion bumps into a chloride ion, it precipitates out. So this one does not break into ions because it's an insoluble salt. It remains the same. Calcium nitrate, on the other hand, does break up because there's an AQ there. So we end up with calcium plus 2AQ and 2 NO3 minus AQs. So now we cross out things that appear exactly the same on both sides. If you notice, we have 2 NO3 minus 1 AQ, and we have NO3 minus 1, and we happen to have 2. So these are spectator ions and cancel out. And the other thing that cancels out is the calcium. So we write down what's left. This would be our net ionic reaction, but we have to remember to simplify the coefficients. They're all 2, so that cancels out. So our final answer, and I forgot my AQs on that one, is this. So that is our final answer. So really, from this reaction, this is the thing that is going on that is changing. Everything else is remaining the same. The silver ion and the chloride ion form a solid precipitate. If we look at this reaction, we're not given the products. This is a double replacement reaction. So if you want to pause the video and write down your products and then figure out if they're AQs or S's, you can pause right now. So with this, here's what you should have whenever you finish figuring out whether these are aqueous or solids and predicting the products. So aluminum and barium swap places. Aluminum pairs up with hydroxide, and we write the correct formula for that. It is insoluble. It's a weak base, so we put an S after it. And here, barium acetate is aqueous. It's a soluble salt. Barium hydroxide and aluminum acetate are both AQ also, this being a strong base. So now that we have that, we have to balance this reaction. So to balance this one, we have to have a 2, 3, 2, 3. And then we have to start breaking these up into ions. This one's a little bit more tricky because we have a coefficient and then we have some polyatomics with parentheses. So we have to make sure that we get the right number. So we have 2 of this compound. So we have 2Al plus 3AQ. 2 times 3 gives us 6 acetate ions. We have 3 barium, and barium is plus 2. And 6 OH minus, 3 times the 2 outside of the parentheses. Draw our arrow. The AlOH3 does not break down because we have an S after it, but the barium compound does, so we get 3Ba plus 2 AQ plus 6 acetate ions that are aqueous. So now we just have to cross out things. So the acetates cross out, the bariums cross out. Now, if you notice, we have 2, 6, 2 left over. So if you don't want to write it out and then have to reduce it down, you could do that in the same step. 2, 6, and 2 are all divisible by 2, so we end up with Al plus 3 AQ plus 3 OH minus AQ yields AlOH3 solid. There is our net ionic equation. Our last example is here. We're given words and we have to predict the product. So sodium hydroxide plus hydrochloric acid. Go ahead and pause this and you can write this out. So here is what you should get. NaOH, which is a strong base, so it's AQ. HCl, which is a strong acid, AQ. We get sodium chloride, which is a soluble salt, so we write AQ. And we get H2O, or HOH. You can write it out as HOH, that's fine, which we know is a liquid. And we know that this reaction does happen because we have a liquid. So that means that NaOH breaks apart, so Na plus AQ plus OH minus AQ. HCl breaks apart, H plus AQ and Cl minus AQ. NaCl breaks apart, Na plus AQ and Cl minus AQ, but water does not break apart. So we cross out our spectator ions, and we're left with OH minus AQ plus H plus AQ yields H2O liquid, which is just the formation of water. Any time we have a strong base reacting with a strong acid, it's going to have the same exact net ionic equation, this one right here.